One known is that when an object is at rest, the net force acting on it has to be equal to 0 because it's not accelerating in any direction. This is also true for an object that's moving at a constant velocity, but right now we're worrying about it when it's just at rest. So an example problem which can illustrate this is that we have a sphere of mass m hangs from two strings that each make an angle of 30 degrees with the horizontal, as shown in the figure above. What is the tension T of one of the strings? So this is an image of what's going on in this problem. So to start off, let's draw a free body diagram of this mass m. So the forces acting on it are gravity directly downwards, just mg, and the tension T. Like this. And so we want to divide up the tension into components which work with our xy axes, which I'll illustrate like this. So the angle is 30 degrees, and we can divide tension up like this. So the x components are t cosine theta and the y components are t sine theta. So we know this isn't moving, so there's zero net force in both the x and y directions. So the t cosine theta, the two are going in opposite directions, so they cancel each other out. And what we're left with is the y direction, where we have gravity, the force of gravity on mg has to be equal to both of those tensions y components, so 2t sine theta. So our unknown here is t, so we're basically gonna want to just isolate that variable. So what we end up with is t is equal to mg over 2 sine theta, like that. And we know that our theta is 30 degrees, and sine of 30 degrees is 1/2. So we're left with mg over 2 times 1/2, and as we know, 2 times 1/2 is just 1, so we're left with mg, just like that. So we know that tension, one of those single tensions, is equal to mg, and that is the answer D on question 12 of the AP test.